Okay, YouTube, let's have a look at pawn attacks. So I want to continue the same kind of pattern that we had in the other types of attacks. And for pawns, there should be two types of attacks or moves. It's probably more correct to call it moves. There is, let's say, forward moves, which we will encode as a vector of bitboards. And same as before, there's one bitboard encoding the possible moves for every square. And then there is diagonal moves, like that. And we want to define an initialize function, which does something. Oops. Like that. Now, before we go too far, let's also add it in here. And let's go. So we want to do the same thing we normally do. We want to say initialize the forward moves, initialize the diagonal moves, loop through every row and column, and then we say there's a forward move at this position, there's a diagonal move, excuse the horrible variable names, and then we say add that, finally we make the instance diagonal. Yes. Then we simply need to define, oops. Then we simply need to define these two functions. And the row can be I don't know, whatever. And it should return bitboard. Great, let's see if this builds. Cannot find type bitboard. Let's go into utilities and export this guy. Oops. Diagonal. Okay, I am very tired today. There we go, now it builds, and now we need to implement these. So let's imagine that we have here a chessboard. Actually, let me put in some thing like that. Here's a chessboard. Okay, so on the first and the last row, there's no possible move. So we can say if row is 1 or row is 8, then we just return 0. Now the same thing, the reason there can never be a pawn here that goes forward, and if there's a pawn here that goes backwards, then it has no moves, or it should be promoted. And the same thing is true for the diagonal moves. So now if the row is 1, sorry, if you're on the second row, then there's 2 types of moves. There's you go 1 up or you go 2 up. Unless so now here it seems we also need to know the color of the pawn, because if it's a black pawn here, then it can go 1 down. If it's a white pawn, it can go 1 up or 2 up. So how do we do that? We can, for each, we can keep a pair of bitboards, or we can keep like a field for both white and black. In the end, it's the same. Let's do this. And then here we also have to say, and oops. Good. And then here we need to say whether it's white or black. So let's just have a boolean for that. Yeah. Actually, don't we have an enum? So yeah, let's use the enum since we have it. Let's just import it. Yeah, that's good enough. So then we want to do the same thing, but with black. And then we want to, here we want to say black. Okay, great. And this one should say the color is a color and the color is a color. So let's try to build it. Still builds, that's great. Okay, so now if we are on the second row and the color is white, then we can go 1 or 2 forward. So let's say bitboard is equal to set bit row plus 1, the same column, and row plus 2 column. Great. Again, let's try to build it. Still builds. Okay, maybe we should just make a test already. And let's say just second row. Okay, it's not gonna work. Okay, let's say bitboard is forward at here we go, and then I believe defined this function last time. Let's run that using compile. Great. That looks correct. Now let's do this a little bit more systematically. With these pawn moves, we know there's always two squares, so we can say least significant bit is a bit scan of the bit board, and the most significant bit is bit scan backwards. Forget which one. It's with an S. The bit board, and then we can make an assert that this should be equal to, and now we can do a loop like row in 1 to 8. We do all this, and also for column, I guess. Column, and okay, so oops. So the expected row is row plus 1. No, wait. We expect to get 2 non-zero. So the least significant bit should be row plus 1, and the other one should be row plus 2. So let's say expected least significant bit is it's the index of that bit. So that should be column minus 1 plus row plus 1 minus 1 times 8. And the expected most significant bit is the same but plus 2. And then we can do this. Great. Now we can run it. Expected U size found I32. So if I do like this. Wow. Oops, I'm stupid. The row is of course fixed to be 2. Okay. And now it passes. So let's do the same thing, but for a black pawn. And now there should only be 1 bit, so we can get rid of that. We could also test there's only 1 bit, but whatever. And it should be row minus 1. And it failed because of what it should have hit the to do, right? It's because we need to say it's black. Great. So it panicked at not implemented. Great. So here we say else if 2 and color is black. Can put that up here, I guess. Then we just set a bit at. Now it should work. Now they both failed, of course. Okay, so it should be white. I'm making so many mistakes today. And then it should be black here. Now they both pass. Okay. So now we should do the same thing, but kind of inverted. If we are on the 7th row, then there's only one possible move. Actually, we can optimize this a little bit. So let's handle maybe white, black separately. And here we say turn bitboard. Okay, so if we're on the 2nd row, we already know what to do. It's this. Now, if we are not on the 8th row, then it's this. So actually we can optimize it or condense it even more. So we have to say if row is less than 8, then we do that. If row is equal to 2, then we do that. And that should do it. So that's if we're white, and if we are black, then we want to say if row is equal to if row is greater than 1, then we can always go 1 down. But if the row is equal to 7, then we can also go 2 down. See if we broke anything. No, didn't break anything. But now we can write some more tests. Let's say test middle rows for the white pawn. So now we want to say for row in not 2, but 3 to 7. Yeah, let's do it like that. And again, there should only be 1 bit, because there's only 1 possible forward move. And it should be this. Okay, so I think you can see where this is going, so I'm going to write these tests, and then I'll come back. Okay, so here we are. I've added some tests for the middle rows, where it goes to each row that is not one of the places where a pawn can move 2 squares. It says that we get what we expect. And then I added a test for the edges. So in the 1st and the 8th row, if a pawn ever gets there, it should be promoted, or it should not be able to get there at all. So just by convention, I've decided that the bitboard should be 0. And those tests all pass. So now let's start implementing the diagonal move. And we can use the same. No, we can make it even simpler. We can say so let's make the bitboard again. If it's white, then and the row is less than 8, then the bitboard should have some extra bits, +1. So how does this set bit work? Let's have a look. Okay, it does do checking of the bounds. So this should be safe. And if it's black, it's the same thing. Except that black pawns, they go downwards and the row has to be not less than 8 but greater than 1. And then we return the bitboard. Actually, let's do it a little bit more in the Rust style. Okay, so that was easy enough. Now let me just implement the tests. Okay, so now I've made a few tests. First, we test that it correctly calculates diagonals for the middle rows, for the middle columns, also the middle rows. Then we test the same for black, and then we test the edges, like if you're in the first or the last column. And there's not too much interesting here. You just have to be sure you are using plus and minus in the correct places. So now we have these functions. Now this should also just work. Let's just write a test that it actually can initialize without panicking or anything. But other than that, I'm not too interested in testing that the contents are correct. We've kind of already done that by testing the functions themselves. But maybe you want to add that in your own code. So let's run it. And everything passed. Okay, so that's it for the pawn attacks. Now I think before the next video I have to think a little bit, because now I want to put everything together and actually start generating some candidate moves based on an input position. And we may have to build some more functionality, gather some more data to do that. But in any case, I have to think about how to do it. All right, until next time.